So this is our first set of notes in this unit. It's called transformations. I want to give you a quick overview of what transformations is, even though we're not doing all of them in this one lesson today. Transformations is the name of the unit. There's 3 types of transformations that y'all gonna learn in this unit. There's not only 3 types, but the 3 types that you're gonna learn in this unit all go together. The first one is translation, the one we're doing today. Later on next week we'll do reflections and rotations. The main reason I want to go over this because a lot of kids get these 2 terms confused. A translation is a type of transformation. These aren't the same thing. And the reason I say that because I'm going to have kids and y'all going to see when I ask later on in the unit when we're doing all of them at once and I ask, hey, what kind of transformation is this? And the kid going to say a transformation or whatever. They're going to tell me the same word back and they really thinking translation. Don't get these 2 words confused. These are 2 different words. Transformation is the overall arcing thing of the unit. Translation is just a single type of transformation. There's 3 that we're going to do. The translation, reflection, and the rotation. You're just doing translation today. So I want to make that clear off the bat. Because I feel like kids always get these 2 terms confused. Because I guess the words are close in spelling. These are 2 different things. Transformation includes all types of transformations. A translation is a single type. It's one thing. Alright. So we're looking at the translation today. First, recall a transformation. Any transformation is an operation that maps a figure called a pre-image or the pre-image. Pre-image. For example, if we were dealing with a triangle, it would be triangle ABC will be our pre-image. And then onto a new figure called the image. And if we were talking about the same triangle and we use the same letters, the image would be A prime, B prime, C prime. That is how we would notate it to distinguish between the 2. So your original image is called your pre-image. The resulting image after your transformation, any transformation, is called your image. A transformation can change the size, position, or orientation. So that is true, but the only type of transformations we're going to focus on right now are the ones that change position and orientation. The type of transformations that we do in this unit will not change the size of our figures. All we're going to do is change the way they are turned, the way they are flipped, or we're going to slide them to a different position. We're not going to change the size of our image. So in this unit, when you do a transformation, if your image becomes smaller or larger or the shape turns different, you know you did something wrong. When you're doing these transformations that we do in this unit, your image should look the same as the other image. It should just be in a different spot. So that's one way I used to always tell my kids, you'll know you're wrong if when you move your image, if it don't look the same as the other one still. If you start out with a square and you end up with a rectangle after you move, you should tell yourself, you know what, I did something wrong. If you start out with a triangle where all the sides look the same and then you get a triangle where one of your sides is way larger than the other 2, then you probably did something wrong. When you move your image, the image should look exactly the same. Alright, a translation. To vertically and horizontally slide a figure. That's what we call a translation. It's just a slide. All you're doing is sliding this one. So when you do a transformation, the main thing you should know about your image is that all the letters and stuff should be in the same position. It should just be that the image should be shifted over. Up, down, left, right, however we want to move it. In symbolic form. Showing you this transformation in symbolic form, and that just means using like the coordinates, your original x and y coordinates would map to, that's what this arrow means, and I'm gonna write it on top, a change in x, and I'm gonna just make this up. I'm gonna say x plus 1 comma y plus 1, or a change in y. That's the main way you'll see transformations written. This is also called a mapping rule. There's my red pen. There it is. So this arrow right here means maps to, and maps just means to move. Let me zoom in. That's what that arrow means. So when I read this, if I have y'all read a translation rule for me, you'll say XY maps to whatever the mapping rule is, x plus 5, y minus 3, or something like that. That's how you would read it. You wouldn't say x comma y arrow. The arrow means maps to. Alright. Another way you'll see a translation rule written is in vector notation. And this is where they'll just use a capital T, telling you that you're doing the translation. And then they'll just put a coordinates inside of, instead of parentheses though, they'll put them inside these little arrow brackets. And the same rule will be written as 1 comma 1, or it could be whatever you want to make it. Alright. So in these rules, like I said, the x plus 1 represents the change in x. This is telling me how to change my x value. It's telling me to all my x values add a 1. In that rule, the y plus 1 is my change in y. I forgot to delete that off of here this year. I always forget to delete this or line. We don't never use it. I don't know why we got it written down there. I forgot to delete it. It's all good. Don't worry about that. So that's basically what you need to know for a transformation. You're not probably going to understand me. I'll probably feel intimidated, but you're not going to understand it until we apply it. Once we apply it, it's easy. This is not a hard thing to do. Translation is the easiest one. So down here in our examples, directions says graph and label each point and its image under the given translation. Give the new coordinates. So we start out with the rectangle QRST with vertices of Q, -6, -1, R, -3, -1, +1, S, 1, -5, and T, -2, -7. The translation rule is our XY maps to X plus 5, Y plus 7. So they're telling us how to translate this image. First we got to put it on the graph. Now, a couple things. In this unit you're probably going to use it a lot too, because I can't provide y'all with rulers just because of the situation we're in. And I don't have that many rulers like that anyway. But this unit specifically, my kids used to always use their IDs. If you have an ID, that's probably the best thing to do, because you're going to have to graph images and make straight lines and stuff. So, but if you don't have ID, anything that you can use as a straight edge will work. If you have a ruler, roll with that. But if you don't, you might want to use your ID. But you're going to need a straight edge to keep your images looking crisp. Other thing, well, once you figure out what you're going to use, we're graphing these points, Q, R, S, T. These are our pre-image points. I need my glasses on. So -6, 1, 2, 3, 4, 5, 6. 1. -3, +1, 1, -5, 1, 2, 3, 4, 5, -2, -7, -2. I almost messed up in pen. -2, -7. There we go. Alright, now we're looking like a rectangle. So what I do first, and that's just me, I put all my points on first so I can see, and the next most important thing before you connect your lines is to put your letters on. I put all my points on first just so I won't write my letters on the inside of my figure. Now that I see what my figure looks like, I know where to write my letters at. So Q, but this is important. If you don't write your letters, and I'm going to tell y'all this now, I say it 1,000 times every year, but some kids still do it. If you don't write your letters or label both of your images, I will mark your paper wrong. I don't even care if you got the images correct. If I can't read your letters to see what your images are supposed to be labeled as, I'm going to mark your stuff wrong. That's probably the most important thing to me. Because when y'all get stuff wrong and you trying to figure out what you did wrong, a lot of y'all didn't label or didn't label correctly. So after you connect your points, you should see some semblance of a rectangle, especially if you're using something with a straight edge. After that, they want us to translate this image, x plus 5, y plus 7. So y'all should know this is our x-axis, our y-axis up here. X plus 5 is a change in x. So it's a change in the x-axis. If they're saying plus 5, we're adding 5 to our x values. Which direction are we moving? To the left or to the right? To the right, right? Right, how many spaces? To the right, 5. Then it says y plus 5. Y plus 7, excuse me. Y-axis here. We're doing plus 7. We're moving up or down? Up 7. So knowing that, we really could just count our points, but I'm going to show you the mathematical way to do this. The reason I want to show you this is because sometimes the translations y'all have to do are big numbers. Say it's like, I don't know, x minus 13 and then y plus, I'm just making this up, but y plus 15. That's a lot of points to sit there and count each time to try to move all your points. There's a mathematical way you could do it. It's not hard. I mean, you just adding and subtracting to your points and getting the new values. You're just doing math instead of actually counting on the graph. But you could do either way. But I'm going to show you the math way. So I'm going to take my original points, Q. He said it was a -6, -1. And I'm going to leave a space in between. I'm going to write R next, leave a little gap there. R is at -3, 1. Make sure you write down what I'm writing down, Tim. S is at 1, -5. and then T is at -2, -7. All I did was pull the original coordinates they gave me off here, and I'm writing them down here. Writing them down here so I can do some math, like I said. To each one of these coordinates, I'm going to apply my change in X and change in Y. My change in X, we said, was to the right 5 or +5. So I'm going to add 5 to each of my X values. +5, +5, +5, +5. My change in Y was +7. +7, +7, +7, +7. And then out here, I got my spaces over here for my image coordinates, which is with the primes on it. So these, I hadn't explained this to you yet. These little, I guess we call them apostrophes, whatever. We call this prime notation. This is distinguishing our image from our pre-image from our image. And so when you put the stuff on the graph, and you'll be able to see once we do the other figure. You'll know by looking at a graph, if two images are on a graph already, you'll know which one is which one you started with just by looking at the notations. That's the reason we notate, so we can know what the difference between the two is, which one we started with, which one we finished with. So just doing this math, -6 + 5, -1, -1 + 7, what's that, 8? No, 6, I'm tripping. Y'all help me out, man. Yeah. -3 + 5, 2, 1 + 7, 8. 1 + 5 is 6. -5 is 2. And then 3 and 0. Thank you, man. So we go that route. We don't have to count. We just do the math real quick, and then now we can graph. Now what I was talking about, well, I'm about to graph these. Before I graph these, what I was talking about with counting. So we did the math on Q, right? And we got -1, 6. Everybody agree with that, yes? What I'm talking about with counting is some kids like to just count, but it takes a long time. So instead of doing the math, we could just go on the graph and say, okay, we know it's from Q, it's +5, +7. So you go to the right, 1, 2, 3, 4, 5, and then you go up. 1, 2, 3, 4, 5, 6, 7. I put a point there. That point is at -1, 6. So you could, count your points over and do the translation as well. But some kids find the math easier, especially when your numbers are big. Instead of just counting everything, they find it easier just to do the math real quick and get their points. It's really up to you. I can't specify which one you want to do. Find one that you like and roll with it. I won't mark you wrong either way. Next one, so 2, 8. So over 2, up 8. That's my R prime. Then 6, 2. So over 6, up 2. That's going to be S prime. And then 3, 0. Over 3, stay at 0. This is going to be T prime for me. Once again, you'll know you did it right. And when you translate, your image looks the same. Just looks moved or shifted over. So this is my image after the translation of X + 5, Y + 7. Now, like I said, you can count it if you want it. So, but you don't have to. But all these points should be translated over the same amount. So for Q to Q prime, it was 1, 2, 3, 4, 5, Then we went up 1, 2, 3, 4, 5, 6, 7. You can even check with the S's too. So S was over 1, 2, 3, 4, 5. Then went up 1, 2, 3, 4, 5, 6, 7. All the points should be translated the same distance. Like I said, you can count if you want, but for me, the bigger the numbers get, the easier it is to just do the math. Just translate by changing your X and your Y values, write your new coordinates, and then go plot those coordinates from 0, 0. And then you'll have your translation. Or if you don't want to do the math, you can sit there and count like this and get your new points. Alright. On the back, graph and label each figure and its image under the given translation gives the new coordinates. Same thing, just another practice problem. This time it's a rhombus JKLM with the vertices. You see JKL and M. We're going to plot those original points. Then we're going to do a translation of XY mapping to X plus 2, Y minus 2. Alright. I'm graphing my original image first. -4, 7, 0, 8. -1, up 4, and -5, up 3, 1, 2, 3. So I have J, K, L, M. So this is my rhombus, JKLM. They want me to do this translation, and I'm gonna write the stuff again for you. I mean, X plus 2, what are they telling me to do? Well, yeah, which direction are they telling me to go to? I'll come back to you. Just save me on X plus 2. Still don't get that concept on the graph, huh? I'm on the x-axis and they asked me to go plus 2. I'm doing what, Billy? Going to the right 2. Y minus 2, Billy. Down to it. Now that's if y'all want to move on the graph. I'm going to do the math out to the side again, even though these numbers are small. So J was at -4, 7. K 0, 8. L -1, 4. m left negative 5, excuse me, comma 3. So plus 2, plus 2, plus 2, plus 2, minus 2, minus 2, minus 2, minus 2, negative 4 plus 2, negative 2, 7 minus 2, 5, 0 plus 2 is 2, 8 minus 2 is 6, negative 1 plus 2 is 1, 4 minus 2 is 2, negative 5 plus 2, negative 3, and 3 minus 2 is 1. These are my coordinates of my image. I'm going to graph those. Go another color. I start switching colors after a while. I'm about to switch now. Uh-oh. J prime is at negative 2. Up 5. 1, 2, 3, 4, 5. Here. K prime 2, 6. L prime 1, 2. And M prime is at negative 3, 1, 2, 3. Up 1. Here's my image after my translation. Y plus 2, X plus 2, Y minus 2. So obviously at some point I'm going to turn this over. Number 2. It says, what are the vertices of the translation? Negative 3, 8. And you got triangle CDE. So I told y'all, we always try to do this for y'all. We try to show y'all problems different kind of ways. This problem is no different than the last one. It's just that we changed the way we wrote it. They're talking about the triangle CDE. That's the pre-image. They want to know what the triangle will look like after a translation of negative 3, 8. So we just didn't write a whole mapping rule. They wrote it in vector notation this time. But negative 3, 8 is telling you to do what? Go ahead, mama. Move to the left 3, and then go up 8, right? Yep. That's what that notation is telling me. Alright. Graph your original image. Do the translation. Now you're either going to do the counting on the graph, or you're going to do your math out to the side. Either one will work for me, as long as you get it right. Let me pause. All right, coming back. Only thing I will do, I'm not gonna do the drawing, of course. I'm not gonna do the drawing, but I do want to know the coordinates. Zoe, give me the coordinates of your image. Now I'm writing in pen, y'all. That's good. Hello? Oh, okay. Y'all stop me if ain't. -1, 7. Go ahead. A little louder. 4, 4.
Yes.
1 and 2. All right. Sliding on. So the last two, and you're gonna have to do this for us too. Not hard at all, but this is why it's important, Tim, to use prime notation on your images. So up there, when y'all drew y'all images, I should have been able to distinguish between which one you started with, which one you finished with, which one was your pre-image, which one was your image. Reason being, sometimes we put two images on the graph and we want to know from you, like down here, number 3, what is the translation rule for the images below? And so we're going to write it as a mapping rule. But to get the mapping rule, we need to find out what translation happened. So who can I bother for this? Huh? Okay. Well, Tim is going to help me with this one. Tim, and to get the rule, first, you need to identify which one was the image, which one was the pre-image. Tim, the one to the left or the right, which one was my pre-image? The one on the left, right? Alright, so to get the rule, I'm need to count from this one to this one. Now, all you're doing is picking any 2 points. You should know all the points are going to be the same distance apart. Any 2. And when I say any 2, I mean like D and D prime, or E and E prime, or F and F prime. So from D to D prime, Tim, what was your horizontal change?
7.
So 1, 2, 3, 4, 5, 6, 7. Yeah, we lined up under D. That's the case, Tim. Was this a +7 or a -7? So down here on my rule, I got XY maps to X + 7, and I'm gonna go back up. Tim, what's my change in Y? +4. You went up 1, 2, 3, 4. That's 4. So Y is Y +4. So my translation would have been this: XY maps to X + 7, Y + 4. Yeah, I'll do the last one. I had a rule describing this translation. Shouldn't take you too long either. Jeremiah, what you got? Huh? Just give me the rule, man. Give me my mapping rule. Which one? You said 2 different things. So what is it, man? Can you read the whole thing to me? I'm so sorry, sir. You were going so slow. Lucas, you got it?
Yes, sir.
Alright. Give me the whole thing. Give me the whole thing. X, Y. Uh-huh. X what now?
X plus 4, Y plus 2.
Amber, what you got? X minus 4, Y plus 2. You gotta make sure you move in the direction you're supposed to move. The first move on this one is back to the left. It's 4 spaces. Then you go up 2. So that's a minus 4. Represent it right in your translation. Yeah, that's it. So that's translation, kiddos.